Hello, and thank you for watching this video announcing the release of Communication Drivers Pack 2020.1. This release introduces an independent MQTT subscriber that supports the Eclipse Foundation Industrial MQTT specification, otherwise known as Spark-Plug-B. MQTT is the predominant protocol in IoT solutions and continues to gain widespread adoption in real-time, mission-critical SCADA environments. Designed to be deployed in a geographically distributed system, MQTT with Spark-Plug-B is the most efficient protocol for transmission of data in bandwidth-constrained, high-latency, or unreliable network conditions. Unlike other protocols that use poll response for communication, MQTT uses publish and subscribe and report by exception. Rather than a constant stream of requests and returns that consumes valuable bandwidth, data is only sent when a value changes or when a device state changes. The end result is maximum data transmission efficiency. When using MQTT in SCADA systems, support for Spark-Plug-B is essential. Spark-Plug-B defines and standardizes topic namespace, the details of a message payload, and manages device state awareness, all while maintaining interoperability. Let's view a couple of demos, starting with a demo on connectivity, browsing, and the geolocation map. For our MQTT subscriber to get data, we must first set up a publisher. Here we have set up a node in Aviva Edge. The highlighted areas show the group, node, and device information, as well as the tags we are going to view in our MQTT browser. Now we'll connect the publisher so it starts publishing data. We can see in the output area that our connection is good. Switching to the System Management Console, we can see that the MQTT broker has been configured with connection information, has been set up for encryption with TLS using certificates, and requires user authentication for additional security. Now when we switch to the browser, we can immediately see that the device and the tags have been detected. As you add more nodes and devices to your system, the interactive browser automatically detects those items until the user has a fully populated browser representing everything to which MQTT is subscribing. On switching to the browser geolocation view, again, nodes and devices automatically populate on the map. All of this discovery is made possible by the MQTT listener even before we've connected to the MQTT broker to start collecting values. Now let's take a look at a successful failover between two broker connections. In this image, you can see the configuration for connection to the first broker, called California 1. An additional connection has been configured, pointing to a different broker, consuming the same data, and it's called California 2. Finally, configuration of a redundant broker has been set up to point to California 1 as the primary connection and California 2 as the secondary connection. And now we'll switch to see a screen that shows the object viewer on the left with tags added to the watch list, and the System Management Console on the right, displaying the configuration just described. You can see that the active connection is California 1, and all values are coming in with good quality. In a moment, California 1 is going to be shut down, but pay attention to the object viewer. The switch from good quality coming in from the primary connection to good quality coming in from the secondary connection is very quick. You might want to watch that again. And now we'll fail back to the primary connection. Finally, here you can see in the SMC under Diagnostics and Devices that live values can be viewed directly from the console. This release of the Communication Drivers Pack 2020.1, introducing an MQTT subscriber, is a first step in the end-to-end story for MQTT support. Coming soon, this driver will support both publish and subscribe, multi-broker support, live values in the browser, and auto build and provision. And that concludes this introduction to Communication Drivers Pack 2020.1.